Hello and welcome, my name is Amir, and in this video we are going to solve yet another beautiful puzzle from the Codewars website. This one is called Sequence of Power Digit Sum, and let's dive right into it. So first, let's take an integer number calling start, and let's do the iterative process described below. We take its digits, raise each of them to a certain power n, and then add those values up. We would get to R1. Then we repeat the same process with the values of R1, which was here, and so on for k times. So we have three entries, start, n, and k. Let's do it with start 420, n3, and k5. We raise 4 to the 3, 2 to the 3, and 0 to the 3, and add them, we would get to 72. Do the same thing with 72, we get to 351. Do the same thing with this, we get to 153, and then 153, and again 153. So we can observe that it took 3 steps, 1 step, 2 steps, and then 3 steps to reach to a cyclical pattern, 153. And the pattern has only one item in it, which is 153. So h is 3, like the steps is 3. The length of the cyclical pattern is 1, because there is only one item inside the array. And the last term of our k operation is 153, because this is being repeated. Okay, now let's see another one. The number is the same, power is 4, and the repeat is like 30 times. So we start with 420, we get to this pattern, which will repeat here. So after like 1, 2, 3, 4, 5, 10, like 11, like 12, after 12 steps, we get from 420 to a number that will repeat, or is the beginning of the cyclical pattern. In this example, we can observe that cyclical pattern is this one, with a length of 7, which is obvious. And it took 12 steps going from 420 to 13139. And the last term is, after doing 30 operation, is 1138. Notice that we don't need to go to the 30 when we get this cyclical pattern, because this is going to repeat. So if, for example, this was like 3000 times, and we find the cyclical pattern, then we can do the division of 3000 minus this number 12 and divide it by 7 and find the remainder, which would give us the last item, because this is repetitive. Then we need to make the function this that receives arguments in the order shown below, so start, then n, and then k, and it should send back this output, h, which is the number of steps, the array of the cyclical pattern, which is this one, its length, and the last term or last value. So like this, and this is the values for start, n, and k. So yeah, we can do it. So before I jump right into the code, it would be nice if you pause the video and try to solve it by yourselves. Otherwise, you can join me in finding a solution. So let's go. Train. Let's grab this part. Come here. And let's start. So first I need to get the operation on the start. So I would say like s is, I would convert it to string, then I will split it by empty string to get each of the numbers as a character. So if you see s here, and if I run this like with 420 and 3 and 5, So this is the S array now, and then I would convert them back to the numbers. So map them to, let's say, number. Actually, I can just send in the number function here, like so, and it will be the same thing. Okay, now I need to raise each of them to power 3 and add them together. So I would reduce it using an accumulator and a value, and accumulator plus the math dot value and n, and we are starting at 0, of course. So this will give me 42, which is the next step, going from 420 to 72. Okay, so instead of having it in a new variable, I will add it to the start, or actually I'm changing the start so that I don't need more variables. So I need to store this value in the array so that I know if I get to a cyclical pattern or not. So I need a for loop here, going from 0 and let's say to k, of course, but not the k itself. I can put this inside here, and I need to have a array of the values, which is starting empty, and here. When I do this, I will check that if the start is inside that array or not. So values dot start, sorry, not values dot includes start. If this is included, then we are in a cyclical pattern. We would break, like here. We would calculate, and then do this, and then when we get to this, we know that we get to a cyclical pattern. So we break, otherwise we just add the number to the values array. So values.push the start. Awesome, great. Now if I take a look at the values, I can see that I get 72, 351 and 153, just like here, and I don't get these two, which is fine. Let's go with these two values, n4 and k30, and you can see that we get to this value. So let me log it to see it better. Yeah, you can see that this is the value that we have. Awesome. The last one should be 9219, which it is. And this is the number that is repeated. Okay, but how do I know that which number is the beginning of the process? This start value here will remain the same. So if I see the start here, it's this one. Now I can get the index of this, and that is the beginning of the cyclical pattern. Okay. X is values dot like so, and if I like the index, then it would be 11, which is correct. But I need to add 1 to it when I want to return it, because the array starts from 0, of course. To return are basically this index plus 1, and then, like, was it 3 more things? The array itself, the length, and the last thing. So yeah, 4 things I need to return. The array is going from this index to the end. So I can say that R is the values that I slice them from index onwards, if I can spell it correct. And this would give me the R. If I log it here, this is correct. 1, 2, 3, 4, 5, 6, and 7 items. Great. So this one is R, and the next one was the length of the array, which is 7. And the last one, as I said, when we get to here, actually here, this is my array. I need to remove these elements and divide the k minus this number of the values, and then divide it by this and get the remainder, so that the repetitive numbers go away. So that would be let's say last value. That would be the R at this index k minus the index -1, and then this should be divided by the length of the array, which is r dot length. Let me see last here. It is 1138, which is, I believe, correct. Awesome. So this should work fine now. Let me do it with 3 and like 10, not 0 but 10, and see the last item here. 153 is correct. Great. So let's copy and paste this and see if it's working fine. Okay, we have some problem. Let's go and see what we are missing. This is the number that we need to bring in. This is the last. So last here, attempt again. Now it's passing. So let's submit it and we're done. So yeah, this was the puzzle for today. I hope you have enjoyed watching the video. Until the next video, goodbye.